So in this video, section 1.4, we are going to solve another similar problem as the previous video, which is how to locate root 3 on number line. In the previous video, we saw, this was the previous video, we saw how to locate root 2 on the number line. Okay. Now we are going to see how to locate root 3 on the number line. Now the process is exactly the same. Okay. We use a Pythagoras theorem to locate or to find a right angle triangle with the length of under root of 3. So let's begin. First, let's try to draw a number line. So this can be, okay, I'm going to need a lot of space upside. So let me just draw it down. Okay. So this is our number line. We have, so let's say this is 0 and this is 1 and this is 2 and this is 3. So these are our whole numbers that we put on the number line 0, 1, 2, 3, and this side we have negative numbers. Now we have to locate an irrational number on this number line. So first we follow the same procedure that we did to locate root 2 on the number line. So what we did for root 2 was, now let me zoom in. Yes, what we did for root 2 was, this was our line of length 1. Let us label it. So this is our point A and this is our point B, which is of length 1. Now we do a construction of another line perpendicular here, which is of the same length as of AB. Okay, the length of this line is same as AB, which is 1, and we'll name this point as something called as Q. Then we construct the hypotenuse AQ. Okay, this is our right angle triangle. Okay, so let me note it down here. Triangle ABQ is a right angled triangle. Okay, so using the Pythagoras theorem, we have, okay, so yes, using Pythagoras theorem, we have AB square plus BQ square as equal to AQ square. Okay, but what is AB? AB is 1. What is BQ? BQ is also 1. So 1 square plus 1 square is equal to AQ square, and therefore we have 2 as equal to AQ square, and therefore we have AQ as of length under root of 2. So AQ becomes length of under root of 2. Okay, very important point. So I'm going to mark it down here. AQ is of length under root of 2. So let me just write it down. This is under, okay, let's use a different color to note down the lengths. Okay, this is of length 1, this is of length 1, and this is of length under root of 2. Okay, now what I'm going to do is, and thus we get, okay, and thus we mark root 2 on this number line. What we do is we assume A as the center of our compass, and from Q we draw an arc which intersects somewhere here, and that becomes root 2. So in fact, let me do that construction. Yes, so we just complete this arc and it will intersect this number line somewhere, and that, since it's a circle, so AQ and this A, let's name this point, let's call this as P. Okay, so AQ will be equal to AP by the property of circle, and thus we get root 2 on our number line. So let's in fact mark it. This is my root 2. Yes, so this point, this number on my number line is 0, this number is 1, this number is 2, this number is 3, and this point on my number line is under root of 2. This is how we locate root 2 on the number line. Exact same procedure and exact same concept we are going to use to locate root of 3. Now how are we going to do it is, we are going to construct another right angle triangle here. Okay, we are going to construct another right angle triangle here with AQ as the base of our triangle. Okay, so let's do it. Let me use a different color. Yes, so I'm going to draw a perpendicular line here of length 1, which will be perpendicular to this AQ, and let me mark it in fact. So this is a perpendicular line AQ, and important point is it is of length 1. Okay. So and now once again I am going to complete this. Okay, let's label this point. Let's call this point as what should we call it? Let's call this point as R. Okay, let's call this point as R. So now I'm going to again complete this hypotenuse from A to R. Okay, it's not going straight. Yes. So let's draw this hypotenuse of our right angle triangle AQR. Okay. Once again, let's revise what we have done. We had this AQ as our one line. Okay. We have drawn a perpendicular line to AQ. Okay. So this is perpendicular, and the length of this line is 1. So this is 1 and this is root 2. And thus we now get a right angle triangle ARQ. So let's make a note of that. Okay. So triangle ARQ, or rather I'll say AQR. Triangle AQR is right angle triangle. Triangle AQR is a right angle triangle. Okay, by the way we have constructed this triangle, and since it's a right angle triangle, Pythagoras theorem applies. Okay, so once again, using Pythagoras theorem, okay, we have AR square, because AR is the hypotenuse, AR square as equal to AQ square plus RQ square. Okay, this is the Pythagoras theorem, because this is the base AQ and this is height RQ and this is our hypotenuse AR. So the hypotenuse square is equal to the base square plus height square. That is the Pythagoras theorem. Now we know what is AQ. AQ is root 2. So this is going to be root 2 square. So I'm going to write here root 2 square plus, we know RQ. RQ is the line which we have constructed. So we have constructed it to length 1. So that will be equal to 1 square. That will be equal to 1 square. Okay. And root 2 square is nothing but, okay, root 2 square is nothing but 2 and 1 square is nothing but 1, which is equal to 3. Let's zoom in. Okay. And therefore we get AR square as equal to 3, and therefore we get AR as equal to under root of 3. AR is of value under root of 3. So let's come back to our right angle triangle, and thus this value is under root of 3. Okay, now the construction or the concept is exactly same as how we found AQ of length root 2. Now we have found AR of length root 2, and now we are going to do the exact same thing what we did while finding this point P. We are going to take A as our center and length of our compass is equal to AR, and we are going to draw a circle which goes and intersects the number line. Okay, once again you have to imagine a huge circle. Okay, imagine a huge circle here with A as its center and AR as its radius. The length of the radius is equal to root 3. So AR as its circle. So just for a quick understanding, let me draw a circle here. Okay, so imagine this circle, and now this is your radius, sorry, this is your center A. Okay, so this is your center A. Okay, and imagine this as your point R. Okay, and let's assume this is of value root 3. Okay, so now, and imagine this another radius which is A, let's say Z. Okay, so clearly AR is equal to AZ, because that is the property of a circle, that all the radius is of equal length. Now from AR, if you draw this arc and you reach this point, then you get this point Z. So similarly this is AR and I want to draw an arc, and somewhere it will meet this number line and I will get my point Z, and then I will say AZ will be equal to AR, because that's the radius of the circle, and thus I will get AZ of length root 3. This is exactly the same concept what we used to locate root 2 on the number line. The only thing is we have this double construction. First we found out root 2, then we found out root 3. So that might be a little confusing. However, conceptually the same thing is happening here. Okay. So now let's do that construction. I have to use another color. Okay, so now I'm going to let's say brown. So I'm going to do this circle construction. A as the center of my circle and AR as the length of my radius. I'm going to construct another circle. So this circle will go somewhere down. So you have to actually take a compass and do it. Okay, and it will intersect somewhere here on the number line, and let me call that point as point Z. Okay, so this is point Z. Okay, it's a little bit, so this is my point P. Let me in fact erase this. Okay, and yes, let me put the name here, P. Okay, so this is my point P here, which was root 2, and this is my point Z, which is going to be root 3, because AZ is going to be equal to AR by the definition of a circle. And thus I have my point root 3 here, again very next to root 2. So this is how you locate under root of 3 on the number line. It is going to be between 1 and 2, because the value of root 3 is roughly equal to 1.7. In fact, let me write it down here. So root 3 is okay. So root 3 is roughly 1.71 and root 2 is roughly 1.41. This is the decimal value. So this is how you locate irrational numbers on the number line. So every time you have to locate the irrational number on the number line, the basic thing you have to do is you have to get a right angle triangle with their hypotenuse as that value, root 3, root 2. Tomorrow they'll ask you to locate root 5 on the number line. So again the same concept has to be applied, and you complete this circle and find the point which is on the number line.